So piecewise infinities. Basically what this means is that your graph is either going forever to the left or forever to the right. That's why it's called infinities. So our first example that we have here is f of x equals negative x plus 3 if x is less than 2, or 2x minus 3 if x is greater than or equal to 2. Yes, you're going to write this down. So we're going to be graphing if f of x equals negative x plus 3 if x is less than 2. And then we're going to be graphing 2x minus 3 if x is greater than or equal to 2. Okay? These are called one-sided inequalities, right? Because they're one-sided, they're telling me I'm going to one direction or the other. When I am less than, that means I'm going to the left. When I'm greater than, that means I'm going to the right. Make sense? Less than left, greater than right. Okay? So just like before, we're still going to identify our breaking point, our boundary. So our breaking point here is where? Is at 2, right? So 2 is our breaking point. So at 2, I'm going to go one way to the left and one way to the right. After you identify your breaking point, then you're going to evaluate. After you evaluate, then all you're going to do is complete the graph in the right direction. Okay? So first here, we are evaluating x is less than 2. So when I substitute 2 in, I evaluate, right? What is negative 2 plus 3? 1. Is it going to be an open or closed circle? Open. I'm a hungry gator, right? So I go to 2 and I'm going to go to 1 and I have an open circle. Because it says I'm going to the left, I'm going to find my slope and go to the left. What is my slope here? What kind of 1? It's a negative 1. My slope is negative 1. Do we see that? Casper the friendly 1. mx plus b, things we should already know. Okay, so because my slope is 1, that means from this point, I'm going to go up and to the left, right? Up to the left, up to the left, up to the left, up to the left. I can keep going until I want to stop, or I can just stop at any point. That's what it means by evaluating. I'm using my knowledge of slope to complete that line. I'm going to connect, complete the graph. And that is my left side behavior. Okay. And then I'm going to repeat the same for the right side. So the right side, I plug 2 in. What is 2 times 2? What's 4 minus 3? 1. Am I going to be an open or closed circle at 1? It's going to be closed. So I go to 2. And now I go back to 1. And now I'm going to close it. I'm going to complete the graph by using the slope. What is the slope here? The slope is 2. And I'm going to the right. So I go up 2, 1, 2, and to the right. Up 2, right, up 2, right, up 2, right. And there is the rest of this graph. So in the case of this problem, the domain, because I go forever to the left and forever to the right, my domain is all real numbers. It goes from negative infinity to positive infinity. Do we see that?
Yes,
it is today.
I don't know how to draw it.
It's like 2 zeros next to each other, an 8 taking a nap, Harry Potter's glasses. I've heard it called everything in the book. So whatever you want to call it. All right, how do we feel about piecewise and infinities? Doable?
Who invented it?
Huh?
Who invented it?
I don't.
I want to stop it.
I don't know, William. I can't give you that information. All right, guess whose turn it is to try? Yours, okay? The difference here is this one. Is this a linear? It's not a linear, is it? It's a square root. So therefore, I don't have functions that I can plug in, and I don't have a slope I can follow. I'm just going to plug in numbers. Plug in a couple numbers to figure out the shape. Okay? All right, so I want you to try. Identify your breaking point. Identify which one goes left, which one goes right. And I'm going to give you like 90 seconds to just try and process. Okay? Because you just looking at me, waiting for me to give you information isn't really you learning. Okay? Learning is you doing and you trying. Got it? Hit it. So on the first one, how do we do at 0? Was it easy?
Yeah.
So the first one is just a plain old linear, right? And when I go to 0, it's going to be an open circle. My input is 0. My output is 2. So at 0, I have an open circle at 2. And then to complete the graph, I use my slope. My slope is -1. So I'm going up 1, left 1, up 1, left 1, up 1, left 1. And you get it, right? There's my left side is done. Because less than means left. Now I'm going to the right side of it. So to go into the right side of this, I have 0 being plugged into this square root function. So when I plug 0 in, 0 squared, the square root of 0 is 0. 0 plus 3 is 3. So my output is 3, and it's going to be a closed circle. So I go to 3, I'm going to close the circle. Now, to finish this, I'm going to plug in values because I do not know, like I'm pretending that I don't know the shape of this, but I do. So I'm going to plug in perfect squares. And the reason why I'm telling you to plug in perfect squares is because I'm taking the square root, right? So my perfect squares are f of 1, f of 4, f of 9. Those are my 3 smallest perfect squares. Does that make sense?
Mm-hmm.
So the square root of 1 is 1. 1 plus 3 is 4. My output is 4. The square root of 4 is 2 plus 3 is 5. The square root of 9 is 3. 3 plus 3 is 6. Does that make sense? So my points that I can plot, I'm going to go to 1, 4. I'm going to go to 1, 4, 4, 5. And I'm going to go to 9, 6. And I'm going to follow those points to complete my graph. Okay? The right side was meant to give you a bit of a challenge. See how you would process that. Did anyone choose square root friendly numbers and find those values? Yeah? You tried? That's all I can ask. All right. Questions about example 2? Okay. Example 3. What happens when I have a combination of it all? We just work through it, right? So number 3 is where everything comes together. Okay. So here we have, oh, we didn't write our domain. What's our domain here? Are there any gaps in our function? Are there any breaks? So our domain is all real numbers from -infinity to positive infinity. A snowman taking a nap? All right, here's our next one. So this one is a combination. On our first piece, we have a beginning and an ending, right? At our beginning value, is it going to be open or closed? It's going to be closed. And its end is going to be open. We're going to do this without putting breaking points, just because when you graph it in the calculator, are you going to see breaking points? No, we will not. Okay. So -7, I'm going to substitute in -7. What do I get when my input is -7? The output is, if you owe me $7, you're like, hey, miss, here's one of the dollars. How much do you still owe me? 6. So my output is -6, right? Because you still owe me $6. So when the input is -7, my output is gonna be -6. Yes? Huh? Oh. My input is now 2. What is gonna be my output? 3. Does that make sense? My input was 2, my output is 3, and at 3, it's gonna be a closed circle. And now I'm gonna connect these two pieces. Rise over run, what is the slope here? 1, Casper the Friendly 1. So up 1, over 1, up 1, over 1. This just helps me draw a straight line. If you can draw a straight line without it, more power to you. But this helps me draw the best version of a straight line I can. Bless you. Okay. All right, we have 2 minutes to finish. So here it says that literally at x equals 2, what is it? -7. So when I'm at 2, I'm equal to -7 is just the point. Okay. And then our last one is now we're going to go to the right. When I substitute 2 in, when I input 2, what is -2 plus $10? If you have a -$2 balance and you go deposit 10, what is your new balance? 8. And at 8, is it open or closed?
It's open.
Open. So I'm going to go to 2, and I'm going to go to 8, and it's going to be an open circle, and it's going to continue to the right. This time my slope is negative, so I go down and to the right, down and to the right, down and to the right, and I'm going to just draw the arrow out from there. Okay. This function is continuous because every x value is defined, and our domain, where did we start? Where did we start on our x's? We started at -7, but do we ever stop? No, so we go on to positive infinity, okay? So that's putting it all together. Your assignment is on Canvas, okay? Your assignment is due Monday. When is it due?
Monday.
Monday.